Hello, and welcome to our Computer Science Honours Project. My name is Laaiqah Hassim, and my partner's name is Yash Ramsamy. Our supervisor is Professor Hussein Suleiman, and we present MESH, a concept map tool for mapping cultural heritage. Digital archives preserve and retain knowledge in the form of text, photos, video files, or a combination of these. Digital content stored in these archives contains simple items, and the relationships among these items and their context are not clear. To illustrate the context and relationships of digital content, researchers often produce research papers and other artifacts, such as timelines or diagrams. Ideally, researchers would produce and interact or view these in a digital form, as well as be able to archive it for future use. There are tools that exist to visualize this data, for example, content management systems or diagramming software. These have limitations. Sites created in CMSs cannot be exported into a format that allows it to be preserved back into an archive. Diagramming software such as Lucidchart allows created mappings to be exported, but in a static representation. It would be favorable for researchers to produce and store interactive mappings of data. To tackle this problem, we plan to investigate the design, implementation, and capabilities of an experimental concept mapping system that allows users to create and visualize digital content and the relationships between them. Our prototype consists of two main services: Complex Object Creator and Editor, and Complex Object Mappings Renderer. Each team member was responsible for implementing one service. My individual contribution to this project was implementing the Complex Object Creator and Editor, also referred to as COCE. Alongside this service, other accessory features that I completed was a login system for user authentication and a project workspace, which is a screen displaying a user's current projects. With the COCE, I intend to investigate the experience of users when using an integrated concept mapping and complex object creation tool to create and edit digital content. COCE has two main functions: creating and editing concept maps and storing and manipulating concept maps. Before creating a map, a user is required to first enter a title and description for it. These details are displayed on the home screen's project list. A map consists of nodes and edges. Nodes hold the information in three layers: a title, description, and details, all of which play a different role during concept map visualization. The details can be formatted with different types of headings, bullet points, and hyperlinks. To connect nodes, a link is formed by clicking one node and dragging to another. Once a user saves a map, the data is sent to the database. Information collected are saved in a MongoDB document database, hosted on Atlas, stored on the cloud. This image shows the structure of a single MongoDB map document stored in the map collections. Other accessory features I implemented to ensure a well-rounded web application is a login system for authentication and a workboard screen, which is the home screen displaying the list of projects a user has to work on. When a project is clicked on the home screen, a menu pops up with a list of functions a user can perform. A user can view a map online or offline, which is the functionality of the COMR, which is later discussed. A user can also edit a map. Participants from varying levels of education and specializations were used to evaluate COCE. Evaluations were conducted remotely via an online questionnaire, where users were required to perform a list of tasks, rate it, and give feedback on it. The use questionnaire was used to collect user feedback, which assesses a user's subjective usability when using the app. The use questionnaire measures usability in four categories: usefulness, ease of use, ease of learning, and satisfaction. Ease of learning scored the highest ratings with an average of 4.55 across all its items, with ease of use following close behind with an average of 4.21. These ratings reflect in user feedback where they commended the simplicity of features and the ability to grasp how to accomplish tasks quickly. The satisfaction ratings had the lowest average of 3.56 from the four categories. The design of COCE was simple enough to perform tasks easily. However, it also lessened the engagement and enthusiasm when using the application, resulting in a low satisfaction rating. Overall, ratings suggest that the users were pleased with COCE. Results suggest that the COCE is promising and that users are interested in this tool and its future potential. This general experimental system can be modified with advanced features such as linking maps or archive dumping to create a specialized concept map creation tool that can be used in different academic niches dealing with large amounts of data and who are interested in categorizing and condensing the information they see into concept maps. This concludes COCE. Now Yash will discuss the COMR service.
My individual contribution to this project is the Complex Object Mappings Renderer, also referred to as COMR. Alongside this service, other accessory features that account for its service is the textual index and exportation. The COMR attempts to answer the question, what is the user experience when viewing and manipulating complex digital objects such as concept maps, and whether it is a feasible solution for understanding digital object relationships. COMR renders outputs from the COCE into a visualized concept map displaying the relationships of the objects. The concept map itself is represented by a textual index, which is a textual representation of the map. The concept maps can also be exported into a self-contained zip file. These exported maps can be viewed offline without any internet connection in a user's browser. In the concept map view, we can see that the map itself is zoomable, pannable, and clickable. Every node on the map is clickable. Clicking on any one of these nodes reveals the title of the node and a brief description of the node, as well as an Explore More button which takes them to a full description of the node. Taking a look at the node content view, we can see when clicking on the history of South Africa, it loads a web page filled with information about this node. This information is styled and formatted from within the COCE and rendered here in the COMR details page. This is the textual index, a list view of the concept map. This list is searchable in three ways. One being a search query that must contain the search term within any of the node's descriptive fields. The second being at any of the start of the node's descriptive fields. And the final search query being an equals search query, where the search term must exactly match the search term given. This is the exportation feature. It can be found in the options menu in the COCE dashboard. Clicking on View Offline allows the user to download the map as a zip file. Much like the evaluation stage for the COCE, the COMR will also undergo user evaluations. They will be given a list of activities to do, and the results will be recorded in terms of how well the activities were completed. The two main overarching tasks for users to evaluate are rendering created digital objects relationships as a concept map and viewing digital object information through the concept map, after which they will perform standardized user evaluations in the same process as the COCE. This concludes my contribution to the project. The use questionnaire measures usability in 4 categories as mentioned in the COCE results. Ease of learning also scored the highest ratings in the COMR with 4.5 across all of its items, with ease of use as the second highest category with an average of 4.2. The satisfaction category earned a score of 3.8, and usability earning an average score of 3.9. The median scores for all of the categories were at least 4 and above. This reflected in the design of COMR. It was simple enough to perform the required tasks easily, but the simple design lessened the engagement and enthusiasm when using the application, resulting in the low satisfaction rating. However, the overall rating suggests that users were pleased with COMR. So in conclusion of the COMR, the results from the investigation found that it was easy and understandable to use. However, some improvements can be made, such as real-time collaboration, improving the overall design and aesthetics of the COMR, having immediate access to the exportation button on the concept map webpage, or even an interface where the COMR and the COCE are on a single page. So for MASH as a whole, we wanted to determine if it's feasible to create and use an interactive concept mapping tool. This investigation was met with limitations, such as remote user evaluations. Owing to the COVID-19 pandemic, we were unable to source enough participants from the cultural heritage domain. Thus, we allowed participants to map content that is unspecialized, and as a result, we conclude that MASH, for a general use, is usable and feasible. Thank you for taking the time to watch our presentation. This marks the end of the MASH project. Please feel free to look at our final papers and our website for more information.